How to build a model steam engine. This is the Stuart Models Victoria Part 6, Machining the Crank Web. The first thing to do, as always, is clean up the casting. And this one had quite a big lump on the end of it, which I took off with the bandsaw, and now I'm using the 1-inch belt sander just to clean up the part. It's quite a tidy casting, not a lot of work to do. This crank web casting may look like a very simple component to machine, and indeed it is, but it's not that easy to get it 100% accurate. The main point is, the hole down the centre that takes the crankshaft has to be perfectly in line with the hole that will take the crank pin. I'm starting off the process by fitting the cleaned up casting in my 3-jaw chuck, and what I'm currently doing is using a square to make sure that the front face of it is square. The casting is firmly held in the chuck because I cleaned it up, and the chuck is holding it by real metal, not just by sand and scale. And what I'm doing at the moment is just gently tapping the part to get it as square as possible before machining it. There are 2 things to do when you tap a component in a chuck. One is don't tap it too hard, otherwise it will end up in several pieces. But the most important part, although that is arguable, the most important part is once you've tapped it into position, retighten the chuck jaws and check that it's still square. Because generally speaking, if you tap a component with a hammer that's held in a chuck, it does become a bit looser than it was to start with. So once you're sure that the component is firmly held in the chuck, because if it jumps out of the chuck it's going to be destroyed, it's time to take a very gentle cut across the front of it. Because of the shape of the component, a lot of the cutting is going to be intermittent, so take gentle cuts. Do not advance the tool fast at all. Otherwise, something nasty may happen. Either the component will break, or it could jump out of the chuck. Either way, this spells disaster. But that's just not going to happen, is it? If you take your time with this and keep the cuts light, then everything will be fine. And then the sun will come out and the birds will start singing. It's Friday the 8th of September 2017, it's 8:35 in the morning, and I'm doing this voiceover and it's absolutely pouring down outside. So once again, it's not going to be a good day for running a steam engine in the middle of the garden. At this stage of the operation, it's quite important to decide how much material you're going to remove from each side of this part to make it look like it does on the drawing. If you don't take enough metal off this side, the crank web will look large and ungainly, and if you take too much off, then the crank web is going to be weak. So constantly have a look at the drawing. If I stop the lathe for a moment, you can see that the crank web looks to be about right. So I think I'll leave it at that. The next step is to use a centre drill in the tailstock chuck and drill a deep centre in the work. And follow this by drilling all the way through with a twist drill that is 1 imperial size less than the finished size that I need. And please note, the hole in this crank web is 3/8 of an inch in diameter, and the crankshaft needs to be turned down at the end to fit into this from 1/2 inch to 3/8, because I've modified the size of the crankshaft, but the crank web is exactly as per drawing. In these tutorials I frequently say 1 imperial drill size less than the finished size that you need. Quite a few viewers have asked me, well, what size is that? So hopefully, to avoid these questions once and for all, thanks to information found on Google, here is a chart showing the imperial drill sizes. So now there's no need to write in and ask me the question. The next part I need to make is nothing to do with the crank web. This is a mandrel on which to mount the crank web for the rest of the machining operations. This piece of metal I found in my scrap box started off life as being part of a crankshaft that actually snapped off. And in this clip I'm machining it to accept the crank web. When making a mandrel this way, it is very important never to remove it from the 3-jaw chuck until every operation is completed. If for any reason you remove this mandrel from the chuck and then refit it, it will not run true. Generally I use Loctite 603 for securing components onto mandrels. And here it goes on, a quick tap with the hammer. And usually while the Loctite 603 sets, I go into the house and make a cup of tea. After an initial facing cut, I use my ruler to measure how thick I need this to be, and I look on the drawing, and on the drawing it shows this part of the crank web has been 3/8 of an inch thick. So a couple of fine cuts later, and it is 3/8 of an inch thick. And now I'm going to use the smallest centre drill that I have. But I'm not drilling a deep centre hole, I'm making a very tiny mark in the end of the mandrel, and you'll see why shortly. The outer part of the crank web, and that's the part that takes the crank pin, needs to be 1/4 of an inch thick. So I set the size first of all on the micrometer, and then I double check it using a twist drill. Measure twice and cut once. The end part of the crank web is quite a long way from the centre of the chuck, so I'm taking quite light cuts because I don't want to snap it off. And don't forget that the lathe is not running in real time, this is 400% faster. Generally in the home workshop you do need to machine cast iron at quite a slow speed, but the nearer to the centre the piece of cast iron is, the faster you can go. And here's the reason why I put a very small centre mark in the end of the mandrel. It's so that I can set the distance on the compass from the centre of the crankshaft to where the crank pin needs to be. And the next operation is to drill a hole perfectly parallel to the hole in the centre of the crank web. At the moment I'm showing my time-saving device for changing the jaws in a 4-jaw chuck. I turned the handle end of the chuck key to fit in my electric drill. And this simple modification saves a lot of time. Winding the jaws out of the 4-jaw chuck slowly by hand really used to take some time. Now it takes no time at all, and I'm quite pleased with this idea. I've put a piece of mahogany under the crank web just in case the drill was to catch the jaws, but in actual fact it doesn't, so it's not required, it's completely superfluous. This 4-jaw chuck is mounted on the rotary table, but I'm not using the rotary table aspect of it. It's just simply to hold the part securely at a perfect right angle. So when I drill this hole, it's exactly in line with the hole that's currently down the middle of the crank web, which is fitted to the mandrel. And once again, the drill is 1 imperial size less than 3/16. 3/16 being the finished diameter of the hole. And in this clip, I'm using a 3/16 of an inch reamer in order to finally size the hole. I thought that I would take this opportunity to just remove some swarf which was all over the 4-jaw chuck, so it's ready for the next job. And to the man who wrote in to tell me that he noticed that I didn't use my shop vac very often, you were right, I don't use my shop vac very often. A wonderful observation. Over now into the outer part of the workshop, and with the blowtorch I'm heating up the mandrel to destroy the bond of the Loctite. And after loosening the part with an adjustable spanner, a Barco of course, I use a piece of mahogany to tap the part off the mandrel. And you will notice that I'm using a tapered piece of mahogany because I do not want to put any stress on the outer part of the crank web. That's it for machining the crank web. I'm just cleaning it up now on different grades of sandpaper, starting with fairly coarse and finishing with very fine wet or dry paper. In this episode, just as an extra part, I'm going to look at the pedestal. You cannot really finish machine this until you've built the engine and mounted it on its base, because it needs to be a length to accommodate the outer bearing, and that's relative to the size of base that you use. When I was first cleaning up the casting, I squared off the bottom part of the pedestal, believe it or not, on the linisher. And I verified this by using a square, and it is very square at the bottom. So I clamped the pedestal in the 4-jaw chuck, which of course is on the rotary table, and took a very fine cut, or should I say several fine cuts, across the top. So now I know that the bottom part of the pedestal and the top part of the pedestal are perfectly parallel. I'd like to take this opportunity once again to thank my Patreon subscribers. Thank you. But I do need quite a lot more Patreon subscribers before I can open my coconut farm on a Caribbean island, where I could build and repair steam engines on a full-time basis and make many more videos. So if you would care to have a look at www.patreon.com/Keith Appleton, as one word, you will see what it's all about. It's not compulsory, and you can pledge as little as you want or as much as you want, and you can set your own limits. It's very simple, trouble-free and very straightforward, and you can stop it whenever you want. Here's the unmachined casting for the split bearing that will sit on top of the pedestal, so you get the idea. You will find the method by which I make the split bearings quite interesting. So here's the kit of parts so far, looking considerably better than they did originally as rough castings, and there's plenty of scope for painting. Thanks for watching, and I hope you found it useful.